Hi guys. Today what I want you to do is reach into your packet and pull out the multiple choice AP Calculus BC exam from 2013. So you'll look and see the year right here. Okay. So go ahead and pull that out, and we're going to do questions 1 through 14. We'll stop there. Some of them I'm going to cut out because I know there are problems that we're not going to see on the exam. Okay. And so what I want you to do on this is I'm going to want you to answer the question and then watch the video on how to answer it correctly, okay? And just to go through and make sure. Now, if you know that you got it right, because there's in the back of this, I'll tell you there's answers. And if you check your work in the back of the packet in the PDF, you have the answer. So go ahead and check. And if there's a problem that you don't need to see how to do, just skip over it, okay? All right. But again, do corrections with a different colored pen. So I know you're putting the effort out and you're looking at and you're trying to correct your mistakes. Okay, that's all I ask of you. All right, it's okay to make mistakes on this. All right. All right. So go ahead and pause the video and find the first page and the first problem. Okay. Okay, so your first page looks like this, and just go ahead and get started, and go ahead and pause the video and just get through this. This should take you roughly a half hour or so, give or take. Okay, just try to get them right. Okay, we'll get the speed going a little bit later on. Okay, because you're going to have to answer these a little quick. Okay. All right, so go ahead and pause the video, and you can do these one at a time, or you can go through and do them all at the end, okay? However you do the corrections is fine with me, okay? Okay, so we're looking at for problem number one, that f of x is x squared plus 3x plus 2 over x plus 3. Find then f prime of x is equal to, all right, so we should be looking at the product rule, okay? So f prime of x would equal the derivative of the top, which would be 2x plus 3 times the bottom, which would be x plus 3, and then minus, and then the top, which is x squared plus 3x plus 2 times the derivative of the bottom, which would be 1, okay? All over the denominator squared. Now, we don't have multiple choice questions on the AP exam this year, so I want you to work these out. Just don't go over and like, oh, which one can it not be, all right? So go ahead and work this out because you're gonna have to do that for the AP exam, okay? Now that's the derivative. Actually, if you stopped right here on the AP exam, that's the derivative, okay? All right, I'm gonna go ahead and multiply this out. So this would be 2x squared plus 6x plus 3x plus 9, and then minus x squared minus 3x and minus 2 all over x plus 3 squared, okay? So, you know what, and I should have written here 2x squared. Okay, so that should be 2x squared. Oops, okay? All right, so 2x squared minus x squared, that'd give you an x squared, okay? And then 6x plus 3x is 9x, and then minus 3x would be plus 6x. And then we have a 9 and then minus 2, so that'd be plus 7 all over x plus 3 squared, okay? And so that looks like it'd be answer number C, okay? So C would be the correct answer on this one. Okay, for question 2, we want to integrate or find the antiderivative of 5x times the square root of x minus x squared dx. Okay, so I'm going to want to rewrite this, okay? So it's 5x times x to the 1/2 minus x squared dx. So I'm going to distribute this. So this would be equal to the integral of 5x to the 3/2 power minus 5x cubed dx. Okay, so then this would be 5 times, and it'd be x to the 5/2 divided by 5/2, but that's the same as multiplying by 2/5, and then minus 5x to the 4th over 4 plus your constant c, okay? So this becomes 2x to the 5/2 minus 5/4 x to the 4th plus c, okay? So that looks like it would be C again, okay? So the correct answer is C on this one, okay? Next problem. Okay, so for number 3, it's the first BC question that we've seen so far, and we want to find the value of this series, okay? Now, we're going to need to rewrite this series a little bit to figure out the sum, because we need to rewrite it so we can tell it's a geometric series, okay? So this is equivalent to sigma. I'm going to come up here a little bit so I can write bigger. Sigma n equals 1 to infinity, and because we're adding exponents right here, this would be negative 3 to the n, and then times negative 3 to the first power. Okay, because we would add exponents there. Okay, all right. So then, okay, now what this would be 5 to the n power. Okay, and then we would have we could rewrite this. I'm still going to rewrite this a little bit differently. This is going to be actually, let's not. Okay, so this is going to be sigma n equals 1 to infinity, and it's going to be negative 3, because negative 3 to the first is negative 3. So it's negative 3 times, and we have negative 3 over 5, and we could raise that to the n. So it's negative 3 over 5 to the n. Okay, now what we need to do is we need to find our first term. Okay, so our first term, we put 1 in, right? So it's going to be negative 3 times negative 3/5. Okay, so that would be 9/5. Okay, so that's our first term. Now, if it's a geometric series, we know our sum, okay, which would be a sub 1 over 1 minus r. Okay, so our a sub 1 is this 9/5. So this would be 9/5 over 1 minus our r, and our r is negative 3/5. So 1 minus negative 3/5. Okay, so then the sum here would equal 9/5, and then this would be 5/5 plus 3/5, and 5/5 plus 3/5 would be 8/5. Okay, so we have a complex fraction, so let's multiply the top and bottom by 5, and we get 9/8, and that would be the sum, and so our answer would be letter D, okay? It'd be this one right here, okay? So that would be the answer to number 3, it'd be D, okay? All right, so let's go to question number 4. Question number 4 is really an AB exam question, okay? Because I'm just asking for this tangent line, okay? So here's my equation, here's my point. I want the tangent line. So I got to find the derivative of this, okay? So we got to do implicit differentiation on this, because right here we have a product, okay? So we have x, actually the derivative of x squared would be 2x, okay? And then minus 3, and then I'm going to put a bracket here, and then we're going to do the product rule with x and y. There's other ways to do this, but that's how I chose to do it, okay? So the derivative of x would be 1 times the second function, which would be y, and then plus, because it's the product rule, x times the derivative of y with respect to x, which would be dy over dx. And that's equal to the derivative of 10, which would be 0, okay? Now, this would becomes 2x, and this would be minus 3y, and then minus 3x dy over dx. So minus 3x dy over dx, and that's equal to 0. So let's get these two terms that don't have dy over dx over the other side. So it'd be negative 3x dy over dx is equal to, and when I move this minus 3y over to the other side, it's going to be 3y, and the 2x that's positive on the left-hand side becomes negative, so minus 2x. And then I'm going to divide by negative 3x. So dy over dx is equal to 3y minus 2x all over negative 3x, okay? Now, we got to find the derivative. Here's our point that we want to find this tangent line, so we got to find the slope of that tangent line, so I got to use the point 1, negative 3, and put it into this. So this derivative depends on what the y is and the x. So dy, the proper notation, which you have to use on the AP exam, so dy over dx at, that's the line at, the point 1 comma negative 3 would be equal to 3 times my y, which is negative 3, minus 2 times my x, which is 1, over negative 3 times 1, okay? So then that would be negative 9 minus 2 over negative 3. That'd be negative 11 over negative 3, which is 11 thirds, okay? So I know y is equal to my slope, which is 11 thirds, times x minus, my point that I'm looking at is 1, so x minus 1, and then I would need to shift it down 3, so minus 3. Now I realize none of those look like that because all I have to do is move the 3 over, so it'd be y plus 3 is equal to 11 thirds times x minus 1. It's just different forms of point slope form, okay? And so we look at this and it would be letter E, okay? This E would be the correct answer for this one. Okay, and that's the answer to number 4. So number 5, y equals 1/2 times x to the 4/5 minus 3 over x to the 5th. And we want to find dy over dx. I'm going to rewrite this as minus 3x to the negative 5. So I have y is equal to 1/2 x to the 4/5 minus 3x to the negative 5. And I want to find the derivative of this. So dy over dx would equal 1/2 times, my power will come down, so 4/5 x to the, and then I got to subtract 5/5 from the 4/5, right? Because I got to subtract 1. So that becomes negative 1/5. And then negative 3 times negative 5, because I got to bring the power down and multiply it by it. So that'd be plus 15 x to the negative 6. Okay, so this would be half of 4/5, which is 2/5. And then times 1 over x to the 1/5 power plus 15 times 1 over x to the 6th power. So this becomes 2 over 5x to the 1/5 power plus 15 over x to the 6th power. Okay, and that looks like it would be B. Okay, so our correct answer for this one is B. Okay, all right, so let's go on. You guys, I made a mistake. I wrote the problem wrong and I just selected the wrong one, okay? So be careful on this, okay? It can happen. So it should have been A is our correct answer, right? A is the correct answer on this one. Okay, so let's fix that. So for question 6, we want to, here's the graph of the function f, and it consists of 2 line segments, all right? Find the value of the integral from 0 to 3 of the absolute value of f of x dx. Okay, so what's going to happen on this is, because of the absolute value of the function, this part right here is going to get reflected, and only this part is going to get reflected over the x-axis. So it's actually going to come up right here, okay, and it's going to look like this, and this part's going to be gone, okay, because we're taking the absolute value of it. Okay, so there's a couple ways you can do this. I'm going to look at this as being a trapezoid, okay, and then a triangle and a triangle, okay? So then the integral, and we'd want to write this because we have to show all of our work, okay? Absolute value of f of x dx would equal, okay, so 1/2 times the height. Remember, when the two bases are parallel like this and they're vertical, this is the height, right? So it'd be 1 times the sum of the two parallel bases, which would be 1 and 2. So that'd be 1 plus 2, and then plus 1/2, and I'm getting this triangle right here. So this would be 1/2 times 1 times 1, and then plus 1/2, and then this triangle would be 1 times 1 also. Okay, so this would be 3, so this becomes 3/2 plus, and this would be 1/2, and this would be plus 1/2. And so that would give you an answer of 5/2, which is D, okay? So number 6, the answer is D, okay? All right, and number 7, population Y changes at a rate modeled by the differential equation dy over dt equals 0.2y times 1,000 minus y. Okay, so what we have to do is we have to recognize that this is a logistics differential equation, okay? And this right here, we talked about this right here, this 1000, and we did it really quick because it was really easy when we did this, okay? That's the carrying capacity. Okay, so that number right there is always going to be the carrying capacity, okay? And a logistics curve looks something like this, okay? And it comes up and grows exponentially and then flattens out, okay? And right here is where it turns, okay? So and there's a horizontal asymptote, I should say that, and that's at 1000 because that's the carrying capacity. And then right here, this is 0, okay? So this point right here where it's growing the fastest, okay? So right in here, in this part of the logistics function, it's increasing at an increasing rate. But then right here, it's still increasing, but now it's a decreasing rate, okay? So the second derivative of this is negative. So if you look at this, okay, the whole thing is going to be increasing, all right? So you could take a look at this and take a look at the second derivative and figure out where this is negative, and you could do it that way. But the fastest way is to realize, okay, this point right here is midway between 0 and the carrying capacity, which is 1000. So this Y value is right here at 500, okay, because that's halfway between. Okay, so what happens is the carrying capacity is 1000, right? So it's going to be, this population is going to be increasing at a decreasing rate from 500, not including 500, to 1000, and it never reaches 1000, okay? So that's why it has to be 500 less than Y less than 1000 only, okay? So it has, in this question, it has to be C. But really this requires you to understand that this is the logistics differential equation, and it came from a logistics function, and the logistic function looks like this, okay? I'm going to try to do this a different way and show you that too, okay? So I'm going to try to do it from the second derivative perspective, okay? All right. So I looked at this again and I came back and realized, you know what, this is really the only way you can solve this problem is to know the logistics function, okay? That's actually a BC question, okay? All right, so number 8, this is parametric equation. So I'm gonna tell you, let's skip at number 8 because I know for this year, this isn't gonna be asked, okay? We're gonna do it after the AP exam, okay? So let's go to number 9. Okay, so this next problem is an Euler's method problem, okay? And we're going to start at x equals 1, and we want to obtain f of 2, and we want to do it in 2 steps. So to go from x equals 1 to x equals 2, our delta x needs to be 0.5, okay? So we first know that f of 1 equals 0, and then to estimate f of 1.5, we're going to estimate that by doing f of 1 plus f prime of 1 times our delta x, which would be 0.5, okay? All right, so we got to find f prime of 1. Okay, so dy over dx is equal to 2x plus y, right? So f prime of dy over dx, or f prime, actually we need to write dy over dx. Okay, so dy over dx at 1, 0 would equal, okay, 2 times 1 plus 0. So that'd be 2, right? So this would be approximately f of 1, which is 0, plus f prime of 1, which is 2, times 0.5. Okay, so that'd be 0 plus 1. So that would be 1. Okay, now we need to do f of 2. So f of 2 can be approximated by f of 1.5 plus f prime at 1.5 times 0.5. Okay, and to find f prime of 1.5, we're going to use 1.5 comma 1. So we're going to find dy over dx at 1.5 comma 1. Okay, so that'd be 2 times 1.5, that'd be 3 plus 1, so that would be 4. Okay, so f of 1.5 we got from this was approximately 1 plus 4 times, because f prime of 1.5 is 4 times 0.5. So 4 times 0.5 is 2 plus the 1, and that would give you a value of 3. So f of 2 is about 3, okay? And that's using Euler's method, so that would be answer D. So for number 10, we're trying to find the integral from 0 to k of x over x squared plus 4 dx. And we know that that's equal to 1/2 natural log of 4. And we know that k is greater than 0. So k must be positive for this, okay? All right. So to do this, all right, you're going to have to take the antiderivative, okay? You're going to have to integrate. And I'm looking at this, okay, and the derivative of this would be 2x dx. And so I'm picking up my x and dx if I let this be u, okay? So I'm going to do a u substitution. So I'm going to let u equal, okay, x squared plus 4. And then du would have to equal 2x dx. So I need to multiply this by 2 and also multiply by 1/2. Okay, so this is going to be 1/2 the integral from 0 to k 2x over x squared plus 4 dx. And we know that that's equivalent to 1/2 the natural log of 4. Okay, so this is going to become my du. This is going to become u, and I'm going to switch these to u values. Okay, so we have 1/2 the integral of, and if we put 0 in here, this would make our u become 4. And then our k would be k squared plus 4. And we'd have 1 over u and then du. And we know that that would equal 1/2 the natural log of 4. Okay. All right. So to integrate this, we would have 1/2 and times the natural log of the absolute value of u. And we're going to evaluate that from 4 to k squared plus 4. And we know that that's equal to 1/2 the natural log of 4. So this would be 1/2 the natural log of the absolute value of k squared plus 4, and then minus 1/2 the natural log of the absolute value of 4, which is equal to 1/2 the natural log of 4. Okay, and then this would be 4, right? Okay, so I'm going to move this over because these are the same, right? So I have half of the natural log of 4 and a half of the natural log of 4, which would make just natural log of 4. So this would be 1/2 the natural log, okay, of the absolute value of k squared plus 4. And then that's equal to the natural log of 4, okay? And then what I can do is multiply both sides by 2, okay? And then that would give me the natural log of the absolute value of k squared plus 4 is equal to 2 natural log of 4. Okay, and then I can use properties of logarithms, and I can bring my power up. So this would be the natural log of the absolute value of k squared plus 4 is equal to the natural log of 4 squared, which would be 16. Okay, and then I could exponentiate both sides. Okay, and if I exponentiate both sides, that would give me this absolute value of k squared plus 4 would equal 16. Okay. All right. So that would mean k squared plus 4 is equal to 16, or k squared plus 4 is equal to negative 16. Okay. So this would be k squared is equal to negative 20, which can't happen, right? Because we're not going to be able to square root a negative value. Okay. So it's not this one. Okay. And over here, we could subtract 4 from both sides, and we get k squared is equal to 12. And then we could square root both sides. Okay. And we get k is equal to plus or minus the square root of 12. Okay. And so it can't be the negative one, so it has to be the positive one, right? So k has to be equal to the square root of 12. Now, why do I say it can't be the negative one? Because up here at the very beginning, it said k has to be greater than 0. So it has to be k is equal to the square root of 12, which is d. Okay? And that's the answer for number 10. It's D. Okay? For 11, it's another BC question, okay? The third degree Taylor polynomial for a function f at x equals 4 is this Taylor polynomial, okay? What is the value of f triple prime of 4? Okay, so this is knowing Taylor's a Taylor series, okay? So f triple prime of 4 is going to happen when the power is 3. So it's going to be the coefficient here, okay? Now, where does this 1 over 512, because that would be the coefficient, where does that come from? Well, we know from the Taylor series that f triple prime at 4 over 3 factorial would have to equal this coefficient of the cubic term, okay? So that would be 1 over 512. Okay, so I could multiply both sides by 3 factorial, and I would have f triple prime at 4 would equal 3 factorial over 512. Well, what's 3 factorial? Well, that's 3 times 2 times 1. So that'd be 6 over 512. Okay, and then you could stop here, okay, because that would be right, okay, because we're not doing multiple choice, but you could reduce this, okay. So this would reduce, okay, because these are both even. So this would be 3 over, and then half of 512 be half of 500 is 250, and half of 12 is 6. So this would be 256. So 256, okay? And then that wouldn't reduce anymore, okay? All right, and then our answer would be D. Okay, so let's go on to number 12. Okay, so number 12 makes you look at magnitude, okay? So if you look at this, the limit as x approaches infinity of f of x is equal to 0, okay? And you look at all these functions, and they're all fractions, right? So what has to happen for it to go to 0 is the denominator has to have a larger magnitude than the numerator, okay? So if you look at this first one, natural log of x over x to the 99, x to the 99 is going to grow faster than natural log. So this one's going to go to 0, okay? So this would be true, okay, for this one. I know they're not asking true or false, but it would be true for this one. E to the x over natural log of x. Here, natural log of x is in the denominator. That grows slower. So actually this one, both of these would go to infinity, but this is growing faster than this one. So this would go to infinity. So it's not going to go to 0. This one would actually go to infinity. So that's not going to be true, okay? And then if you look at this one, x to the 99 over e to the x. Okay, e to the x grows faster than any value where it's x to a power, okay? Exponentials will outgrow x to a power anytime, okay? So this is gonna be true also. Okay, so the only ones that where this is gonna be true are 1 and 3, so that would be E, okay? So let's go to number 13. Okay, so here's the graph of f prime for 13, okay? And what we want to look at is f of 0 is equal to 20, and which of the following could be the value of f of 5? Okay, so to go from a graph of f prime to finding values of f, and we know one of them, right? This is the fundamental theorem of calculus, okay? So if we integrate from 0 to 5 of f prime of x, and then dx, this has to come out to be f of 5 minus f of 0, okay? Now, let's talk about, we know, okay, and we know that this one, f of 0, this one's 20, right? This one's 20, okay? So the integral from 0 to 5 of f prime of x dx, all right, would have to equal f of 5 minus 20. All right, and they're asking you which of the following could be the value, right? Okay, so how are we going to get this integral? We don't have the function to actually integrate, right? So we're going to lowball it and highball it, okay? So on the low side, what we could do is we could create a rectangle, and we definitely know that this rectangle, if we go from 0 to 5, is going to be an underestimate, right? And then I'm also going to look at what if we make this rectangle also, okay? So this right here is going to have to be somewhere on the low end. It's going to be 2 times 5, which is 10, okay? And that would equal f of 5 minus 20, okay? So adding 20, I would get 30 is equal to f of 5. Okay, that would be lowballing it, okay? So I know f of 5 is going to have to be bigger. Okay, now, but it's not going to be as big as the red one, right? And the red one would be 4 times 5, okay? So that would be 4 times 5, that would be 20. So we have 20 is equal to f of 5 minus 20. So I'm going to add 20, and that would give me 40 is equal to f of 5. And we know that f of 5 must be smaller than this one, because that's more than the integral, right? Must be smaller. Okay, so it has to be bigger than 30, but less than 40. Well, there's only one number that's that. Now, see, right here, it's 40, right? But there's no way it can be that because we're picking up all this extra area, right? Okay, all right, so that area would have to be bigger than the area actually that's under the curve, okay? So this is just kind of eyeballing it and estimating it. So it has to be between 30 and 40, so that would have to be D, okay? So 13, the answer to 13 is D. All right, let's go on to 14. Okay, for 14, we're taking the limit as x approaches infinity of the natural log, and this has x in it, right? So as x gets bigger, this, what we're putting in the natural log, gets bigger and bigger and bigger. So this is going to infinity, okay? This one would also be going to infinity. So we have infinity over infinity. Now that's L'Hopital's rule, right? Okay, so we have to show that the limit, we need to state this, okay? Limit as x approaches infinity of the natural log of bx plus 1 is equal to infinity, all right? And we also know that the limit as x approaches infinity of the natural log of ax squared plus 3, that would also have to go to infinity. So this is a L'Hopital's rule, okay, problem. All right, so what we have to do is this becomes equal to the limit as x approaches infinity of the derivative of the numerator over the derivative of the denominator. So this would be 1 over bx plus 1 times the derivative of bx plus 1. So that would just be b plus 0, or just b, over, okay, and then the denominator would be 1 over ax squared plus 3 times the derivative of ax squared plus 3. So that would be a times 2x, and then this one would be 0. So I'm using the chain rule here, right? Okay, so this would be 2ax, so times 2ax. Okay, so I'm going to clean this up a little bit. This would be the limit as x approaches infinity of my main fraction bar, and this would be b over bx plus 1. And this one would be 2ax over ax squared plus 3, okay? That would be equivalent to the limit as x approaches infinity of b over bx plus 1 times, and I'm dividing by this fraction, so it's going to be the reciprocal, not 2, ax squared plus 3 over 2ax, okay? Now, if we multiply this out, we have the limit as x approaches infinity of abx squared plus 3b over 2abx squared plus 2ax. Now, x is going to infinity, right? So what's controlling the growth in the numerator and denominator? It'd be abx squared over 2abx squared. Okay, so we can actually ignore this part because this is just an x term and this is a constant, okay? So the ab's cancel out, the x squareds cancel out. The answer to this would have to be 1/2, and that would be B. Okay, so the correct answer to 14 is B. Okay, we're going to stop there, and that will be it for today. All right, you guys take care. Bye.